Okay. So let's see. Homework assignment was to update our code to basically unparse JSON, right? So we currently had our thing working for reading in our cave JSON, turning it into stuff that turn it into an object-based thing. Now we want to go through, and I think we have to write what? What's the name of the method we have to write? We have to write export to JSON for every one of these guys. So we wrote an abstract method inside of our JSON variable class. So JSON variable has an abstract method called export to JSON, and this guy then requires anybody who implements or who inherits from JSON variable to have to write this method. Okay, so we'll do this inside of JSON array. So here's our export to JSON, and what does a JSON array look like? Well, a JSON array is a collection of JSON objects. How many of those? Cur-size number of those, right? So what does it mean for a JSON array to convert himself into back into a JSON string? We'll have string answer is equal, we'll start off with the opening square bracket, and we could put a space in there if you want. In the end, we'll say answer plus equals closing square bracket. And then in the middle, we're going to go through and loop through all of our objects and tell them to give us the JSON representation of them. So we have a whole bunch of JSON objects. How many? Current size, many. So we'll say for int I is equal to 0, I is less than this dot cur size, I plus plus. Each time through, we'll say answer plus equals this dot, what do we call it? The objects? This dot value. This dot value at bucket I dot export to JSON. So we'll ask each of our JSON objects to export themselves to JSON, and we'll tack that on to our answer. All right. Finally, we'll return answer from this guy. So that's export to JSON for our arrays. So arrays always start with an opening, always start with a closing. Okay. Now, after each one of these guys, an object's going to convert itself into JSON, right? Now, usually we now have a comma after each one of these guys, right? So if we're rebuilding this JSON, if we go and look at our, where's our cave JSON? When we have an array, like we have right, do we have an array with more than one thing in it somewhere? Right here. So there's an array, and this array has, here's one object. Oh, hold on, we've got some interesting stuff here. Oh, there's only one thing in there? No, there's two. So here's one object right here, first object in our array, followed by a comma, followed by one additional object in our array. Okay, so as we're going through there, we need to make sure we tack on commas to the end of our, where's my JSON array variable? So after that, we're going to say answer plus equals comma. Now, what will end up happening is when we get past this, we have one extra comma on there. Okay? So we've thrown one extra comma because we got our last JSON object. Then we said, oh, well, now we'll go ahead and throw a comma after that guy. And then we spun back up and realized, oh, wait a minute, we're out of things to check. So one thing we can do is we can ask the question in here, if I is currently equal to cur size minus 1, don't do this. So we might say, if I is not equal to this dot cur size minus 1, go ahead and give ourselves the extra comma. All right, so as long as this isn't our last pass through the loop, give us a comma. If it is our last pass through the loop, that is, I is currently equal to cur size minus 1, it will then become equal to cur size, which will then make this Boolean fail. So this is really asking, is this our last pass through the loop? That's what that if statement says. Alternatively, we could have always put the comma on and then taken the substring of it here. So take everything but that extra comma you just tacked onto the end. They both will end up doing the same thing. In this case, we are always asking the question, are we in the last time? So this is a little bit slower, but then we don't have to take a substring here, where if we just always throw the comma on, we would just know that we always have to take a substring off, take the comma off the end of this guy. So that equivalent would be answer is equal to answer.substring, starting at bucket 0, going all the way up to answer.length minus 1. Answer.length minus 1 is the last legal bucket minus 2. That'll cut it off. That guy. So that'll take the substring of it, keeping everything but that final last little, actually no, it is minus 1. That, because it's non-inclusive. So this will take everything from bucket 0 all the way up to, but not including the last legal bucket in answer. And that last legal bucket in answer would be a comma in that case. Make sense? So you can either conditionally put the comma on or always put the comma on and then do this. Can't do both. Okay, because this guy assumes that you have an extra comma. In this case, we would not. So I'm going to dump that line. We'll just ask the if statement. So as long as this isn't the last pass through, we'll tack a comma on there to separate our objects, and then finish building the sandwich right here and ultimately return it. So that's JSON array variable. JSON string variable we wrote last time, so this is going to return this is our escape character to give us a double quote. So it'll be the variable name surrounded by double quotes, followed by a colon, followed by the variable value surrounded by double quotes. That's if it's a JSON string variable. That's how string variables represent themselves in JSON. So every one of our variables knows how to represent itself in JSON. So we've now taught arrays how to represent themselves in JSON. We've taught string variables how to represent themselves in JSON. Let's see. JSON object. JSON objects to represent themselves in JSON. This is similar to what we just did with our array. So we build a sandwich. Answer is the opening curly brace. Answer is the closing curly brace. We're going to spin through, and every single variable we have in here, we're going to go ahead and tack on our export to JSON version of that variable. All right. Now we're going to do the same thing in here as we did in the other one. So we'll say if I is not equal to this dot cur size minus 1. If this is not our last pass through here, we'll say answer plus equals a comma. Okay, so that's how a JSON object converts itself to, actually, hold on a second. Yeah, that's right. That's how a JSON object will convert itself to a, back into JSON. All right, then we'll return answer. So that's our object. So we have a object, we have a string variable, we have an array variable, we should have an object variable somewhere. Here's our object variable. We'll go ahead and implement that method. All right, an object variable is similar to a string variable. That is, we have the name, so we can steal that from string. Let's go into our string variable. So we can go ahead and, I'm actually just going to steal this whole line for right now. So export to JSON for a JSON object variable is going to deal with name the same way as before. Every single one of our variables has a name followed by a colon. And then, in fact, we probably need to do that for this guy too, right? We do. We'll come back to that here in a second. So name followed by a colon. And I'm going to go ahead and store this in a variable for right now. So we'll say string answer is equal to this guy. Okay, except we are not going to tack on the value yet because we need to ask the value, which is a JSON object, to convert itself to JSON. So we'll say answer plus equals this dot value dot export to JSON, and then return answer. So I'll go ahead and steal this real quick so we can put that into our array. So that will look like that. So our array will start off with the name surrounded by double quotes, followed by a colon, followed by the opening sandwich for our square brackets. Oh, 2 equal signs. All right, then JSON object variable, same thing, except we won't have that opening curly brace there. We're also not starting our sandwich here because this guy actually gives us that sandwich. He gives us the opening and closing curly brace. All right, so for export to JSON, we'll create our answer. Answer is going to start off as a variable name, and then we'll go ahead and tack on, well, then we have our colon, and then we're going to be tacking on the JSON version of the object, and we'll return that answer. So that's that guy exported to JSON. Then we have our JSON number variable. This one's going to be pretty much identical to JSON string, except without the double quotes on the second part. So we'll go ahead and implement the unimplemented method. Paste that in here. The only difference is we don't have the double quotes around there, so I don't need that last piece. So here's the name with the double quotes around it, followed by a colon, followed by just the literal value, not a string value for a number. All right, so that's JSON number variable. Then we have a JSON string variable. Then we have a JSON object variable, which utilizes a JSON object. So we get the name object pair. So here's our JSON object. Then we have our JSON array variable, which does the same thing. This utilizes our JSON object. Okay, so now what we should be able to do is inside of driver, after we get our JSON object called the cave, I should then be able to do system.out.println. Let's call this exported, colon, the cave.export to JSON. And we should get something that looks okay. We should get something that looks pretty similar to our input. So exported, here's our start room ID is 0, comma, rooms is all of this crap. Looks kind of like that. And then if we want to test it, this will be kind of funny. So let's do JSON object, the cave copy is equal to we need to do a cave parser. Oh, that's going to do the name of it. 1 second. That takes in a string file name. See, I want to have a second constructor that takes in a JSON, but that guy's also a string. So it would just have a different, it wouldn't be able to tell them apart. So this is what I want to do. I want to say public cave parser string JSON and just say this dot the JSON is equal to JSON. That's what I ultimately want to do. The problem is that Java doesn't differentiate between that constructor and this constructor because they both take in strings even though they have a different variable name. Let's see. Well, just for the sake of argument, we'll make it work. All right. So we'll have a second one of these. We'll go ahead and get the JSON. All this guy did was ultimately build out this string called the JSON. I'll just set the string called the JSON. And I don't use the Boolean other than just to differentiate these two. We don't need this. We're just using it to test the outcome here. So now I can have a second cave parser. Call this guy CP2. And this guy's actually going to take in, I need to move this guy down below the cave. This guy is going to take in the string from our parsed version exported to JSON. And then pass your favorite Boolean value in there. It doesn't really matter what you give it. Okay, so I have my original cave parser that's going to read in from a file. Then I parse that file into a JSON string. Then this takes the name of the file and reads it into a string. Then I parse that into our sets of objects, our JSON object-based collection. Then I'm going to create a second cave parser, but I'm going to build this guy out of a JSON string. What JSON string? The one by taking our original cave, our original JSON object, and telling him to export himself back to JSON. All right? And then we should have our, we can have our cave copy, and this will be cp2.parse. So we'll reparse the exported JSON. Now, we should be able to say cp dot, didn't we have a display? Oh, we just call it toString? Oh, it's not cp, it's the cave. The cave dot display. And then the cave copy dot display. Those guys should be equal to each other. Let's put a little break in the middle there. System.out.println. Put a bunch of asterisks in there. So this guy and this guy should look the same. So JSON object numVars2, JSON object numVars2, start room ID is 0, 2, 1. Looks to be, at a glance, identical. So that's testing our output because we're reparsing the exported version of what we originally parsed. Make sense? All right, so now we have the ability to take our objects and turn it back into JSON. Now, why did we say we thought that was important? And while you're answering that, let me take out this that version we used to. Why don't I go ahead and restart this and let it. Well, that's weird. All right. Go back into driver. Yeah, so that were parsed. All right, so why is it that we said it made sense for us to export stuff out to JSON? What's the advantage of that? Right now, the way we represent our cave is like this, right? Okay, I don't think we're actually building a cave from that guy yet. We've just done all the work to read that guy into an object-based format that we can work with, right? And then we just did more work to turn him from an object-based format back into that. Okay, why would we do that? Is it we're just gluttons for punishment? What's the advantage if I have we're going to have a JSON object implementation of this. We're already able to read that in. And now I'm going to take that, I'm going to build a cave from it. All right, so I have a real cave. And we've already kind of gotten a taste of being able to walk into our cave and move from room to room and that stuff. What's the advantage of being able to ask my cave to turn itself back into JSON? What can I do that I really couldn't do without having this export to JSON ability? Right now, this, go ahead.
I was going to say, it'll show up quick. Well, you already compiled it into cave JSON, so you're going to essentially it'll show up as a display when you're actually playing the game.
Well, let's go this route. Would you say that this is an adequate cave, or is this a very simple cave? 2 rooms, right? 2 rooms, 2 doors. Probably not going to get the real bucks out of our end user base that we want to charge them for this epic game we're building, right? So would you imagine that let's say the level 1 cave, whatever that means, would that guy likely be 40 rooms? Ballparky, it sounds like a reasonable level 1 cave. We have 40 rooms in our cave, and we're going to have various exits for those rooms. And we're probably going to have monsters. We haven't even put monsters in here yet, right? We don't even know why we're in the cave at this point, but we're going to have monsters at some point. Okay, but now we have a generic JSON parser, so we could add monsters into this no problem, right? I mean, let's just real quick. If I just go into driver and let's just do the cave dot display, I can just haphazardly decide I'm going to go into my cave JSON, and here's our room 2, and our room 2 has some exits. And we're also going to say that room 2 also has some monsters. And just for the sake of argument, let's say that our, we'll just say he has a monster for right now, just to keep it simple. So the monster he has is a gorilla. We have a gorilla in this cave room, okay? So not only do we have an array of exits, we also have a single monster in there. So I'll go ahead and save this. We'll go ahead and run this. And now we see that our code with 0 changes knows how to read in a monster. Okay, you want to have a collection of monsters? No problem. So now we'll have, instead of gorilla, we'll call this variable monsters. And now we'll go ahead and give it its value. And its value is going to be a collection. Let's put 3 monsters in here. This is going to be an extremely dangerous room. Okay, and this monster will have a name, and we have a gorilla. And then we have another monster. Here, let's actually kick this down a line here. Just want to keep it consistent with what we were doing up there. We'll say that's good enough for right now. Actually, we probably should kind of have it over here. Sure. Just, oh. All right, so there's our first monster. Name is a gorilla. Second monster is going to be a snake. And third monster be Dr. Locklear. All right. So now, instead of having a single monster, we have a collection of monsters in this room. Each one of our monsters is a monster object, where the object is going to have a name-value pair. So the name of this guy is a gorilla. All right. So we'll go ahead and run this. And now we see that we have, where's our monsters? Monsters, JSON array, monsters. We have 3 monsters. And here's gorilla, snake, and Dr. Locklear. Okay, without changing our parser at all. So you see the power of what we've spent the last several classes building? Okay, now we can do all sorts of stuff with our game because now we're able to generically represent our cave using the JSON standard. And because we wrote a JSON parser, okay, which, by the way, what we wrote here is not built into Java in anywhere near as convenient of a form as we just wrote. So we've literally upgraded Java with what we just did. All right. So in any case, and this is a generic JSON thing, it's possible that somebody could give us something that's technically legal JSON that our code might not work for. I mean, we haven't like stress tested this on a zillion different JSON inputs, but generally speaking, it seems to work on complex JSON, right? I mean, we'll call this complex. This isn't simple JSON anymore. This is a far cry from our original simple JSON file. I don't remember what we evolved that guy to, but yeah, we ended up putting arrays in there. But certainly our cave JSON file is it's scarier than this, okay? So bottom line is, if we had a 40-room thing. At this point, we have 2 rooms. We have one room that's a cave entrance, nothing in there, and then you take one door to the north and you're bombarded with monsters. Gorilla, snakes, and Dr. Locklear. All right? So we should tell him that he made the monster in our game. I'll probably have him be like a boss or something at the end of the cave, probably throwing like erasers or something, and yelling computer science is problem solving. Isn't that like a boring phrase? I mean, it's not like it's necessarily wrong, but isn't it still boring? It's like in our advertisements for the grad program. It's dumb. We should just put a picture of a Ferrari on there being driven by, like, I don't know. Huh? A monkey? Really? That doesn't, really? Or a dog. Well, dog makes more sense. I don't know why, but it seems like it would. Oh, how about this? Ferrari, monkey driving, wearing a shirt that says Code Monkey. That could work. Or being driven by curly braces. So you kind of get cool mixed with nerd. All right. Oh, by the way, I posted about it on all the different Slack channels, but tonight at 7:15, a group of students are meeting in here to watch that Steve Jobs documentary. So if you're interested, it's like a 2-hour-long documentary. It doesn't cost you anything. Just show up here at 7:15 or sometime thereafter if you can only watch some of it. But it's a really good documentary. It's called Steve Jobs, the Man in the Machine. So we're going to rent it off iTunes. And I'll probably make an appearance at some point, but I won't be there at the very beginning. But in any case, I'd encourage you, if you don't have anything better to do tonight, to come and check out that that documentary. It's very true to life. Tells the old Apple Microsoft story as opposed to it being like a movie. You know, it's not really a movie. It's literally a documentary. So, encourage you to come to that. Okay, so in any case, if we had a 40 or 50 room cave and we had to write this by hand, as human beings, would we be error prone in doing this? We just added an array of monsters and had to be careful, right? All right, you know, making sure we had the commas in the right places and didn't miss a closing bracket and curly brace and all that stuff. So could you imagine that if we were designing a big cave, that this is probably not the best format to design our cave in? this is a nice format to represent our cave in, okay? Or in which to represent our cave, if we're not going to do the dangling preposition thing. So computers can deal with this fine. Human beings are going to have issues with this. So now that we can export our cave to this format, wouldn't it be cool if we were inside of our cave and we went into like build mode? Like I mentioned this last time. So I'm standing in the main room and I just say, create exit to the east. And it generated a new room to the east, added an exit there, and literally would export the JSON to our file for that. So at all point, our file would always be up to date with the current JSON version of our cave. Does that make sense? So if we have that ability, then what we can do to design our cave, we can literally walk into the cave and go from room to room to room as we build them. Make sure that the cave feels the way we want it to feel, and then when we're ready, we'll just say save, and it'll export the current cave to JSON and save it to the file. Or we could choose to save it to a different file if we want to have kind of a backup, something like that. Because maybe we have a starter file that just gives us one room, you know, a blank, kind of that's like a blank template. Every cave has to have a starting room. So it gives us that starting room and it just dumps you in the center of a room with no exits, and then you could build it from there and then save it as level1.cave.json or, you know, caveason or whatever kind of funky name we can come up with it. Make sense? So that type of thing. Okay, so this is going to be a kind of our what we're kind of going for with our cave JSON. What we're going to start off with here, well, let's go ahead and let's try to start building a actual cave based on this JSON now that we have our JSON object version of this. All right, so we're going to go ahead and close our JSON number and JSON object value and JSON array value and JSON string variable and JSON variable, and we'll keep cave JSON open for right now, and JSON object. And our cave parser. So we got rid of all that extra crap that we had in there that had everything to do with the JSON aspect of this. And now let's go back to our room and our player. And let's see, do we have anything else in here? What's a room? A room has a, didn't we have a cave or something like that? Or was that part of our, no, cave parser is all about JSON, right? We also have exits, room, player, exit. Okay, so our room, our cave, oh, we only hard-coded caves. So our caves up to this point literally started with a room, the cave entrance or something like that, right? So what we want to do now, and just for the sake of sanity, let's take the monsters off of there. We'll add, I promise we will have monsters. Okay, don't worry about it. We'll have monsters. Have to have monsters. And we certainly have to have Dr. Locklear as a boss. Okay, and he has to be a difficult boss, but he will lose. Because we're going to have overpowered weapons and ninja stars. All right. All right, so having said this, what was I doing? Okay, so we've just gone back to the old version of our JSON that doesn't allow monsters in our room. We put that in there as just proof that our parser is ultimately powerful and we can do whatever the hell we want, right? That's the punchline. All right, so now let's go ahead and we want to, now that we have our cave, okay, our cave is a JSON object, was the collection of the other crap that's in there. We need to now convert this JSON object into its equivalent cave. Okay, that's kind of our next step. So now we've taken JSON strings, turned it into a JSON object-based representation. Now we need to go from a JSON object-based representation and turn it into the equivalent cave. Once we have that, then we can go into that cave and expand our cave and then tell the cave to export itself back out to JSON. Kind of cool? A lot of work, But in the end, we're going to have something that is pretty modular. We can build some cool stuff off of, right? And then what can we do after that? Okay, we kind of keep going down the rabbit hole with this guy. We can lay on top of that a graphical user interface. Maybe it's an iPhone app, maybe it's an Android app, something like that. Where now we actually have a cave crawler that has, it'll probably be kind of 8-bit graphics or something. I don't know if any of you have like a lot of design background, but stage 1, make it work. Stage 2, go down and beg somebody from the graphic design department to come and facelift it and make it look reasonable. But bottom line is we're building the back end to a video game, right? Fine, it looks junky right here because we're just dealing with it in text and stuff like that. But we can certainly see that if we are representing all these things, to move from what we're doing right now to graphical is just putting another layer of interpreting what's represented in a data structure underneath the hood, right? And next semester, the whole course, 300, is about data structures. And we're already being introduced to them right here. We have a JSON data structure. Here's a textual representation of a cave, and here's its object representation. So this is a data structure which is holding all of this information. And once we have it organized in that data structure, just like arrays are data structures, we can do powerful things with them. Okay? But if we were just operating strictly off the JSON and trying to build a cave right off of this without converting it first into, objects, which are easier for us to work with in Java, things would be more difficult. All right, so step 1 here is we want to go ahead and we want to, given a JSON object, okay, given one of these guys from our driver, we want to create a cave. All right, so we're going to go ahead and we're going to create a new class. Okay, and we're just going to call this guy a cave. Okay, and a cave is going to have a private JSON object called the object that it's going to handle. And then let's say, just for the sake of argument right now, let's say it also has a private string name. And we'll say public cave string name. We'll say this dot name is equal to name. And then we'll also have this guy take in a JSON object. So this guy will take in a JSON object, the object. Actually, if we wanted to, yeah, let's do this. This will be cleaner for us. We're going to take in a string file name, which is associated with our cave. Okay. So we'll build a cave, we'll give the cave a name, and then we'll tell it the name of the file that has the JSON in it for this cave. And then inside of here, we'll set the name. We'll go ahead and say, what we call it, cave parser. CP is equal to a new cave parser around that file name. Okay. And then we'll say this dot the object is equal to CP dot parse. And if we want to prove this worked, we can just do this dot the object dot display, just to prove that we move this stuff inside here, right? So that's all our cave will be right now. So now inside of driver, what will we do? So squeeze this down. Oh, I should have just looked at my comments to see how we did this before, right? We don't need that anymore. So now what I'll do, that's the name of our file, cave.json. So now we're just going to say cave, the cave is equal to, let's call this guy level 1 is the name, and that's the name of the file. Oh, hold on. We probably need to actually call our constructor. There we go. That's it. That'll build a cave that has this name and has that file name, the cave constructor will come in and he will set the name of this cave. He'll go ahead and create our cave parser that knows how to read in a JSON-based a file given a file name. We'll go ahead and generate our object out of that. And then we'll go ahead and tell it to display itself, just proving that, you know, we've done everything that we've already done, but now driver looks a whole lot less scary, right? This is the purpose of object-oriented programming. Okay, is that we build the complicated stuff. We build the insides of the telephone, all of these different variables here, all these different classes. And once we have them working, then we house them inside of the nice plastic container that is our telephone, even though we know the scary stuff is in there. Okay? We don't have to see it very often unless we have to make some tweaks. Okay? So now, inside of our cave object, we have a JSON object representation of our cave object. And now we need to interpret that into rooms and exits in our world right now, right? Our entire cave is made up of rooms and exits, and as well as a player. All right, so we probably want to go ahead and have a player out here. Player just a name right now? Yeah, he is. Okay. So let's go out to driver. So we'll build a cave. We'll say player, the player is equal to a new player. We'll have Professor Wall take down Dr. Locklear. Just kind of setting it up, right? Okay. Oh, we can go Star Wars mode here and actually have Professor Locklear take down his father, Dr. Locklear. Star Wars movie coming out, right? So it's like, it's Darth Vader and Luke. What kind of nerds do you think you are? Well, we will. As soon as we get the boss fight in there, we'll actually have a screen capture of the text battle. Okay. Do any of you have Josh Locklear as the teacher? He's big into Star Wars and stuff, so he'll appreciate this. Dr. Locklear's a little old. Like really old. He's a Star Wars fan too, I think. I think he's a Star Wars fan. Okay, so in any case, we'll have our player, and we ultimately need to dump that player into the cave. But before we can do that, we need to give him a place to go. Okay, so we need our cave to go ahead and turn that JSON object representation into rooms and exits. Okay? So here's our room. And if we look at our JSON object representation, so forget about this guy right here. That's actually in our cave parser. Let me just dump that real quick so we don't see it. That's that line right there. So we just made a tiny little tweak. Okay, now we're back. We don't have that piece. So we now have two JSON objects at the top level, and we actually know that our cave is a collection of rooms, right? So we need to make an initial pass and create a collection of rooms. We're going to have a room array for our cave. Okay, we'll start off with that. We also happen to know how many rooms, right? The top level object can tell us about the number of rooms that are in there. So we know the exact size of our cave, of our room array, at least initially. So that guy is a JSON object, and just as a reminder, what can a JSON object give us? Well, he holds a collection of variables, and our current cave JSON, each of those variables, we have the ID of our start room, and then we have a collection of rooms. So our actual rooms is going to be a JSON array. So we're going to have to grab that to build our rooms. All right. So let's go ahead and create our cave given our object here. Let's see. Do I have the ability to give me current size from this? I don't. So let me go ahead and generate a getter for, I need a getter for the variables as well as the size. All right, so now we've put it into this format. Now I need to be able to get it out of this format. So I need to be able to ask a JSON object, how many of you are there? And give me your collection of JSON variables that you contain. Okay, so I need to add a little bit of additional ability to our JSON objects so we can have access to its parts. So we'll go ahead and we're going to source, generate getters and setters. And we're just going to get a get for cur size and a get for the variables, just so we have the ability to extract those. Okay, so we have that now, and that's for JSON object. Let's do this for the other guys too. So let's do our JSON array variable. So this has a collection of JSON objects called values, as well as a current size. So let's give ourselves access to both of those guys. I don't think we currently have access to those. Nope. So again, we'll generate a couple of getters for both of these guys. So get both of those values. We won't let people externally set them yet, but right now we'll allow them to get them. Okay, so we have that. That's our JSON array variable. Then our JSON number variable, same thing. Let's go ahead and give them the ability to get the value from a number. Get value. We'll save that. And we already did this for JSON object, right? Yep. And then JSON object variable. This guy has a value, so we need to be able to get the value. So source, generate getters and setters, get the value. Save that. Then we have our JSON string variable. We're going to give this guy the ability to get the value as well. Yeah. Source, generate getters and setters. Just get the value. Save that. And then our JSON variable, our generic guy here, has a name. We want to let all things that inherit from JSON variables to get the name of the variable. So we'll go ahead and generate a getter in here. Rather than a getter for names and all the underlying variables, we'll create it once at the top level in JSON variable, allowing it to publicly expose for read-only purposes its name. So generate getters and setters. Here's the name, get name. Make sense? All right, so now we've gone through and we've upgraded each one of our little JSON objects. So we opened up the telephone, went through and tweaked and just made sure we had access to reading of those private variables. Not changing them. The only changes happen internally. We can just get the values right now. What is the name of this JSON variable? What is the value of this JSON variable? That type of stuff. Okay? So now we have that ability. So we go back to our cave JSON here and we look at what this guy is. Well, actually, instead of looking at that, why don't we look at this? Our JSON object holds two variables. The first variable has the start room ID. So every cave needs to know about the ID of its start room. Okay? A unique identifier of its start room. Every cave then also needs to have a collection of rooms associated with it. Okay? And this collection of rooms value is going to be an array, a JSON array, and it will have a size of 2. All right, so every cave is going to remember two pieces of information: the ID of the starting room and an array of the rooms contained within the cave. All right, so let's go ahead and build that piece. So we'll go into our cave. So we'll say, we may not actually need that object up there, but we'll leave it for right now. So we're going to say private int. We'll see if that's going to be an int or not here in a second. It's called a start room ID. And then we're also going to have a private JSON. Actually, let's do this as a private room array called the rooms. Okay, we don't know how big that's going to be yet, but we're going to find out here in a second. So we're going to go ahead and we want to ask our JSON object for one of its variables. Okay, our JSON object has two variables in it, right? Two variables inside of our JSON object. One of them is named start room ID. The other one is named rooms. Those are our two variable names. So we need to be able to ask our JSON object specifically for a value or for a variable, the value of the variable given a name. Okay? So let's go back in here. To our JSON object. This is kind of our bread and butter piece here. So he's holding on to a JSON variable array. Every one of those variables has a name. We currently have given ourselves the ability to get the entire array if we're interested. What I'm actually going to do for right now is I'm going to remove that ability. We're not going to allow them to get the entire array. We're going to allow them to get a variable given its name initially. We might put this ability back in, but let's not just give it to ourselves to give it to ourselves. So we're going to create a public JSON variable, get variable for name, and this guy will take in a string name. And what we're going to do is we're going to go through all of our variables potentially. All right, so for int I is equal to 0, I is less than cur size, I plus plus. And as soon as we find a variable whose name is name, we're going to return that variable. Because that's what this guy does. He returns JSON variables given the name. Okay? So we're going to go ahead and we'll say for int I is equal to 0, I is less than this dot cur size, I plus plus. If this dot, the variables at bucket I dot get name dot equals name. Okay, so if the variable we're currently looking at in our variables array has the same name as the name we're looking for, then we're going to go ahead and we're going to say return this dot the variables at bucket I. We found the guy they asked for, so let's go ahead and return it. If we got all the way to the end here and we didn't find anything, we're going to return null. Could also throw an error or something like that, but in the end we'll return null for right now. We've talked about exceptions in here, haven't we? Have we actually thrown an exception before? Okay, well, let's throw it in there just for completeness sake. So, no, I don't want to. That's going to make this more convoluted for right this second. It would be better if we did, but it'll be harder to call this function. So for right now, just don't screw up when you call your function. Give it names of things that actually exist. Okay? So a good rule of thumb would be if you ever get a null pointer exception when you're running our code right now, A good first place to look would be make sure you're giving the correct name of a variable that exists. That is, don't ask for start room ID with a lowercase d. That will give you a null pointer, give you a null value. So make sure you name your variables correctly. All right, so now a JSON object knows how to get us a variable given its name. Okay, so we'll go ahead and close up the telephone again, get it out of there. So we tweaked it, got in there with the soldering iron. Now we're inside of our cave, so we need to go ahead and get the start room ID for this guy. So we're going to go ahead and say get the start room ID. So we're going to say this dot start room ID is equal to this dot the object dot get variable for name start room ID. Make sure you spell it right. And then we're going to get that guy's. We want to get that guy's value. Now this guy doesn't have a value right now because he comes out as a generic JSON variable. Make sense? We happen to know that the start room ID is actually a JSON number variable. He's one of those guys. Make sense? Okay. He's not a generic JSON variable. He's a start room, or he's a JSON number variable. So we need to go ahead and typecast him to that. We're going to say, Java, by the way, this guy is a JSON number variable. That's what he comes out as. Therefore, I can now ask him for his value. What do we call it? Get value. All right, and it's probably going to still have a problem with this for a moment. Okay, so this is how we typecast something. So I'm converting this plain Jane JSON variable into the more refined JSON number variable, because that's what he actually is. We know that when we ask for the start room ID, we'll get a JSON number variable. All right, but in order for Java to be happy with the way we're calling this, we're going to put a couple extra parentheses in here. So this entire thing here will become an animal of type JSON number variable. Those kind of animals have a function called getValue. Okay? We could have also split this into two lines where we grab the JSON number variable first, then use that number variable to call its getValue, but this puts it all on one line. Okay. Actually, we can do this, I think, right? Good enough. All right, so we now have the start room ID. Let's prove we got this. So let's do a system.out.println this dot start room ID. And let's just for right now, well, we'll still display. So the very last thing we should see should be a 0 down here. There's our 0, which matches our start room ID. Okay, so we're able to extract that value from there. Okay. Now, we want to go ahead and get our value for our rooms. Next guy, well, let's see, we'll look at it here. So the next variable name is called rooms, and rooms is actually something of type JSON array. Okay, so we want to go ahead and get our JSON array variable for our dude rooms. So let's grab that first. Go back into our cave. Get the rooms array. So we're going to say JSON array variable. Let's call it AV, array variable, is going to be equal to the JSON array variable version of this dot, the object dot, get variable for name, the name of this guy is rooms. Okay, so now we have that JSON array variable that has some number of things in it. All right, and if we look at that array, here's that array right here. In fact, here, let me just do, I want to check something real quick. JSON array variables, do they have a display? Yep, they do. Good. Close that. So rather than display the entire object up there, let's just tell our array to display itself, because we taught all of our individual JSON things how to display themselves. So this will just prove that we've extracted that one little piece, kind of a big piece of our JSON, but it's a sub piece of the bigger thing. Okay, so we're going to go ahead and try to grab our array of rooms, and then let's just display the JSON of those rooms. Okay, so here's our rooms. JSON array has 2 objects in it. We have an ID. So each of these objects, here's the first object rather. So the first object is the JSON object that has 3 variables, an ID, a name, and an array of exits. Okay, so now let's go and look at our rooms. What does a room take? A room takes a number of exits, it takes a name, and it may or may not have a player in it, and then it has an array of exits. Okay, a room is now also going to have an ID. So we're going to expand our rooms. And we're going to see this here in a second. We out at 11:20 or 25? 20? Okay. So let's at least get ourselves staged for this. So we want to go through each of these rooms, because that's what we have in here, right? Our array is a collection of rooms. So we're going to now build all of the rooms. Okay? Except we should spell build, right? So we're going to say for int I is equal to 0. I is less than how many things are in our JSON variable array? It's going to be av.get cur size. That's the number of things in that array. I++. So let's just do a system.out.println getting room. And we see there's 2 rooms in there, so we should see getting room printed twice to the screen right now. There's our getting room. Okay, so for each of these rooms, what are we going to do? We're going to go ahead and grab a room object. And how do we grab a room object from a JSON array? I'm going to still print out that guy for right now. So here's our room object, or our array. This is our array. Here's the first object. Actually, the first object ends down here. And there's the second one. So that's the first, no, up one more line. That's the first object, and the one underneath that is the second one. So we want to take this object. We want to extract the object at a particular index from our array. So we need to be able to get the JSON object at an index, pass that object to a room, and tell the room to build himself given a JSON object. All right, so I'm just going to put that in a comment right there so we remember that next time. So if somebody, so let's just say extract JSON object for each room and pass it to room to build itself. Make sense? So I'll push this up to GitHub so we have it if you want to study it over Thanksgiving break. All of you are going to do that, I'm sure, right? All right. Otherwise, have a safe trip if you're traveling somewhere, and a happy Thanksgiving, and I will see everybody next Tuesday. No homework.